nice to speak to you about alpines and from a rock garden here at Whitton College. Today I'm going to talk to you about these lovely little plants that you can see all around us. This is our alpine garden area, and these plants have all come from mountainous regions. That's exactly what alpine means, from mountainous regions. So it comes originally from the Latin alpus, and therefore the term alpine came about. True alpines come from mountainous regions, but there's many other plants that can be put within a rock garden situation that are actually not truly from mountainous regions. So therefore they're better termed as just rock garden plants. And examples of these would be miniature roses or dwarf conifers, for example. Now, to live in a mountain where these plants naturally come from, you've got to have pretty special adaptations in order to survive in these conditions. So you can see that they're all really low growing, they're mat or clump forming. The reason for that is in mountainous regions, you've got really fast winds coming through there. So you've not got much of a chance if you've got big, long, tall, leafy stems. They'll just get blown over. What you want to be in order to survive is low and clump forming along as near to the soil as possible. In addition to this, as well as actually getting away from the winds, the soil temperatures at higher altitudes can be so much warmer than the air temperatures. So for example, if you were on a mountain and you had, say on a sunny day in the summertime, an air temperature just above where the plants are could be round about 5 degrees, but round about at the soil temperature could be as much as 20 degrees. So it really does pay dividend to have most of your plant matter in and around near the soil area, for that reason, just for temperature, but also for survival for the stems. So the stems themselves, it's like they've been concertinaed down, and where you've got a leaf and then a bit of a stem and then a leaf, that's called a leaf node, and then an internode in between. The internodes in between the leaves are so much shorter, so it's almost like a plant stem that's had leaf node, leaf node, leaf node, and internode, and so on. It's going and concertinaed it down into these clump forming plants. Another adaptation of alpine plants is that they are really profuse in the amount that they flower. And that's why, I think a lot of people really like alpines, because they're highly attractive and they're almost, they are dwarf in stature as well. So there's a number of different colours that you see for alpine flowers. Some of them are white, for example. White attracts general pollinators. So where you've got a lack of pollinators on an alpine mountain, very often you'll find that you've got white, because that will attract in general pollinators. Where you've got a big bee population, you'll very often find that the alpine plants are either pink or purple, and that's a very attractive colour to the bees. And often you won't find honeybees like you find in most European areas and gardens and natural areas. It's very much, especially in the early alpines, it's bumblebees which pollinate them. They can operate at far lower temperatures than other bees. That's because of the big, thick, shaggy coat that they've got on. And sometimes it's really quite cold in the air, and they'll walk from plant to plant in order to pollinate one from the other. Just in general, in the summer when you've got the flowers open, it can be so much warmer inside a flower than outside a flower. And so very much you will find that the alpine plants have got this open cup-shaped flower, because the cup shape will trap some heat in, and the pollinators you can often find just sitting in there, which aids with pollination before they move on to another flower. Another adaptation that you find with alpine plants, sometimes you'll find, can't see any here at the moment, but very often, sometimes you can find that, especially in the winter, they'll go a reddish colour, and that's because if it's a reddish colour, it's a pigment that's produced within the plants called an anthocyanin. It's a red pigment, and it acts just like an antifreeze to stop the plants from freezing, which it very often could happen within the environment they're in, because it can be absolutely freezing up in the mountains in the winter time. It also acts as a pigmentation that stops UV light from damaging the cells in a plant as well, so the red pigmentation can help with that as well. Now when you're on in a mountainous region, naturally you've got rocks around you, and then from the big rocks smaller fragments gets broken off by weathering, and so naturally you have this sort of scree effect in and around the big rocks where the plants grow between. We're in Writtle College's rock garden here today, and we've got the big rocks to simulate what you would have in the mountainous regions. The ones that we've got here are sandstone, but very often you can get limestone and granite, and other rocks can be used as well. And to simulate as well what you would have in a mountainous region, you can see that we've dressed it off with gravel here, which would be like the natural scree, which would naturally dress it off in the mountainous regions. Now if you've got very heavy clay soil, this isn't really what you would find in a mountainous region. You would have the soil mixed with lots of rock fragmentations and so on, so it would have to be really quite free draining in order to grow the alpine plants in a garden situation. So somewhere like our rock garden that you see here, pockets where you've got soiled areas, if it's heavy clay like we have at Writtle, these would have been dug out, mixed with about 50% of sharp grit, and then re-put back in these areas here before planting, so then planted and then dressed off with the gravel to act like the scree around it.